Okay, so today what we're going to do is we're going to solve square root or cube root equations. So it's basically solving radical equations. If it's a square root, we got to be careful about taking the square roots of negatives. Not good. Or if we have a square root of some value equals a negative, not good. Okay, we've got to be careful of those, and I'll show you how we check those answers. Okay, so let's start with number 2 first. So we're just going to solve like we always do. The first thing I'm going to do is probably get rid of the 2, just like we always do. We're going to divide by 2 first. Divide by 2, divide by 2. That's a pretty simple step. And then I'll have a square root of x plus 1 equals 7. Okay. I'm going to undo the problem, so to get rid of the square root, we're going to square both sides. So if I square a square root, it just cancels it, so cancels out my square root. I'm left with an x plus 1 equals 7 squared, which is 49. Minus 1, x equals 48. That's pretty easy. Okay. I could check my answer real quick. If I put 48 into my original problem, guys watching, 48 plus 1 is 49. I can take the square root of that. So that's a good answer. This is not a bad answer. I'm going to keep it, okay? Okay, example 2. Same thing, except for it's a cube root. So if I take the first, let's divide by 5. Divide by 5. That seems like an obvious step. Cancel the 5. We'll have the cube root of a 4x plus 3 equals 15 divided by 5 is 3. Yep. 1's right. We're going to undo the cube root by cubing, right? Good. Yep. And then my cube cancel. Good job, Alondra. I get a 4x plus 3. 3 cubed is 27. 3 times 3 times 3 is 27. Just going to solve. Minus 3, I get a 4x equals 24, right? Divide, and I get x equals 6. Now, is that a good answer? Sure. If I plug 6 in for x, I'd get, well, 6 times 24 plus 3, and that works. Not only that, but it's a cube root, so I can have negative answers anyway. So I really don't need to check the cube roots, okay? You don't need to check the cube roots, just the square roots, okay? Okay, example 3. A little bit different because I can't really divide by 5. If I divide by 5, it's not going to help me. So I'm going to still square, but I'm going to have to remember to square the 5. So I've got to get rid of the square root, so I'm going to square, and I'm going to square. Okay, I got to be careful with the 5 though. Okay, the square cancels the square root. I'll get a 35. X, because the square cancels the square root. Over here I've got to be careful because I've got to square the 25. 5 squared is 25. But the square cancels the square root for this one, x plus 2. Okay, I'll back up. The square canceled the square root. The square canceled the square root, but I also need to remember the 5. 5 is not inside the square root, so I've got to square root the 5 into 25. Okay, now I'm just going to solve like I always do. I'm going to distribute. 35x equals a 25x plus 50. Minus 25x minus 25x, I get a 10x equals 50. Divide by 10, x is 5. Seems like a reasonable answer, and it is. If you plugged it in, you'd be okay, all right? Okay, number 4 is pretty similar to the one we just did. It really is. I'm going to, again, square both sides. Square both sides. Square root cancels. Just left with an 8x plus 6 equals. The square cancels the square root, but I have to remember to square the 3. So you just get a 9x minus 8x minus 8x. I get 6 equals 1x or x. Okay, not too bad, right? Okay, now 5's going to get a little bit more difficult, but I'll go through it slowly with you, okay? 5 and 6 are going to take a little extra work, okay? Slowly. So, yeah, like right there? How's that? So on 5, I am going to square both sides to get rid of the square root, okay? But you have to be careful because x minus 2 quantity squared, now is not a good time, okay? Is going to be an x minus 2 times an x minus 2, right? And you can, okay? So x minus 2 quantity squared is the same thing as an x minus 2, x minus 2. I'll go slowly, okay? So x minus 2 quantity squared is going to be x squared minus a 2x minus another 2x plus 4, okay? Now, that would simplify into a x squared minus 4x plus 4. Okay, so the reason I did that on the side is this x minus 2 quantity squared is x squared minus 4x plus 4, okay? That's what this is. X minus 2 quantity squared is an x squared minus 4x plus 4, okay? I had to do that work. Here the square cancels the square root. I'm just left with an x plus 18, okay? Now, when I look at this thing, I'm like, oh boy, I'm going to have to deal with that F word, factor. I'm going to have to deal with that F word. Going to have to factor. So let's minus x, minus 18, minus 18. Let's see what we get. We get 0 equals x squared minus 5x minus 14. And lo and behold, it looks like I'm probably going to have to factor, okay? Okay? Yep, 7 and 2, totally agree with Taylor. X minus 7, x plus 2, you agree with that, Taylor?
I do.
Everybody agree with that? But of course we're solving, so my answers will be the opposite, right? Because you set that equal to 0 and solve, and you get 7. So you get x equals 7, and you set that equals 0 and solve, and you get the opposite, which is negative 2. Now, I got a negative. I got a negative, don't I? Can't have that negative 2. I can check it, but even if you put it up here, you'd have a negative 2 minus 2 is a negative 4. You can't have it, so you throw out the negative 2 and just keep the 7. Okay? All right. All right. You ready for example 6? Example 6 is very similar to example 5, and that's why I want to do it again, so that you got a second shot at doing one of these, okay? Slide that over, okay? So step 1, let's square both sides. Now, x plus 3 quantity squared is, I'm going to write it out for you, x squared plus 6x plus 3, plus 9, because it is an x plus 3 times an x plus 3. Okay, so you guys think about the FOIL in your head, because you can do it in your head. That's a 9 though. Think about how that would FOIL and how it would become an x squared plus a 6x plus 9. We're in algebra 2 now, so I don't have to show every tiny little step. You can see how this would equal that, right? Okay, I see the 3 and the 3, okay? Okay, the square root cancels the square, and I'm just left with a 2x plus 14, right? Looks like the F word again.
Oh no.
Looks like we're going to have to factor, okay? So minus 2x. Oh, factor. It's minus 2x minus 14. Minus 14, I get a 0 equals an x squared minus a 4x minus a 5. I can factor that. Okay, what do you guys think? Minus 5, positive 1, you agree with that? It is plus 4x. And I did make a mistake. Caught me on camera making a mistake. Thanks, Will. So how about a positive 5 and negative 1? That looks better, doesn't it? Yeah, there we go. So my answers are going to be just the opposites. X equals negative 5, which we'll probably throw out, and x equals 1. Okay? So let's throw out the negative 5, positive 1. There you go. Thanks, Will. Yeah, all right. You know, 2 things. You're paying attention, and it's quiet. Oh, it seems so obvious to me. Okay?
Wait, what?
I threw out the negative 5, right?
Yeah, but where is the negative 5? Why is that not an answer?
Because I will...
Oh, right there. Okay.
Okay. You ready for the second? Ready for me to turn the page?
Yeah.
Yeah. It's a negative 5, right? And you can't have negatives. Okay, yeah, if you plugged it back in, especially right here, okay? What's negative 5 plus 3? 1?
Yeah.
What's negative 5 plus 3?
Oh, negative.
Yeah, you can't have that, right?
Okay.
Okay, turn the page.
Oh, and
Yes?
Oh,
What's that?
you didn't give me credit. Did you?
Oh, 1, I'm sorry, 1 caught my mistake. Thank you. We got it on camera. 1 caught my mistake. There you go. Okay, you ready? Example 7. Okay, so a 1/5 power means the exact same thing as the 5th root, okay? 1/5 power does mean the same thing as a 5th root. So we rewrite as the 5th root of 3x plus 5 equals 2. And just like we've been doing, we're going to undo the 5th root. So I'm going to take it to the 5th power, okay? So we take it to the power of 5 and the power of 5. The power of 5 with the 5th root just cancels each other out, and you're left with a 3x plus 5. And 2 to the 5th is 32. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Yeah. And now we're just going to solve, right? Minus 5, minus 5. 3x equals 27. Divide by 3. X is 9. And that's a great answer. I like that answer, okay? Okay. All right, you ready for 8? How am I doing, okay?
Yeah. Awesome.
Okay. Number 8. So 1/2 square root, same thing, right? I'm going to rewrite this as the square root of x plus 12, okay? Equals x. So let's undo the square root. So we'll square both sides. Yep, so it'll cancel. So I get an x squared equals an x plus 12. It's that F word again, I think. I do. So let's bring over, no, not that word. Bring over that number, x squared minus x minus 12 equals 0. Make that a 1. It makes it easier to factor. Okay, put a 1 there, just makes it easier to factor. So if I factor x, yep, 3 and 4, how about a minus 4 and a positive 3? Of course, the answer is going to be the opposite because we're solving, right? So the answer is going to be the opposite. X is equal to a positive 4. X is equal to negative 3. We're going to throw out the negative 3. There you go. Okay. There's my answer. Okay. Okay, number 9. Same thing. The only difference is it's going to be an inequality. So let's just graph it or let's solve it like an inequality. Okay. Same thing. The only difference is we have an inequality. We have less than or equal to. So square it, right? So we're left with a 2x plus 4 less than or equal to 16. Right? Minus 4, 2x is less than or equal to 12. Divide by 2, x is less than or equal to 6. That's what we got to do. But you got to be a little bit careful on this one because some values less than 6 won't work. Am I really done, Talus? Talus, am I really done? Is this exactly true? Could I plug in a negative 10? So less than 6 is a little bit ambiguous because I want to make sure that what's inside of here is always going to be greater than or equal to 0. So on the side, I might say, oh, wait a minute, 2x plus 4 better be greater than or equal to 0. Now, I want you to think about the statement I just made there. Okay? What I'm trying to describe to you is that whatever's in here had better be positive, right? I'm saying whatever's in here, I can never let it be negative, right? So let's take a look at this and make sure it is greater than or equal to 0. So let me solve that. 2x is greater than or equal to negative 4. X is greater than or equal to negative 2. So there's a range of values that will work. Negative 1 actually will work. Negative 1 will actually work. Okay, here's where it gets a little tricky. If x were negative 1, I'd have a 2 times a negative 1 plus 4. That's a positive answer, isn't it?
Yep. Why'd you flip it?
Oh, okay, so one more time. Let me go back to this. Okay, so you guys, everybody's good to hear, right? Everybody's totally good to hear, right?
Yeah.
Well, then this statement says that I could even plug in negative 10. Wouldn't this say I could even plug in negative 10?
Oh, okay.
Could I plug in negative 10? So what values could I not plug in? Well, one thing I know for sure, Juan, is this value, what's inside the square root, better be greater than or equal to 0, right? So I said, well, wait, let's set that equal greater than or equal to 0. Okay. And I solve for it and said, well, make sure that x is greater than or equal to negative 2, but less than or equal to 6. And those will be all the values at work. This is a little bit harder, isn't it? Okay, let me push stop.